Assistant Professor Physics in the Department of Physics, Maharaja Jivajirao Shinde College, Srigonda, Ahmednagar. We have completed our first chapter, that is network theorem related to SYBSE electronics subject, and we have started our second chapter, that is study of transistors. And out of this chapter we have covered the points such as what is transistor, what is NPN transistor, what is PNP transistor, what is the working principle behind NPN and PNP transistors, etc. In today's lecture we are going to see the transistor configurations. So let's see what are the transistor configurations. We know that when we consider a transistor, it is a three terminal circuit or three terminal circuit component. It is a component which is having three terminals. It is having emitter, base and collector. We have previously seen what is emitter, what is base and what is collector. So this is a three terminal circuit element, and when we connect this circuit component in a circuit, then we require four components or four connections, and in order to get four connections we have to take one of the connection as a common. It means that we are having emitter, base and collector, but in order to connect this transistor in a circuit we will require two input connections and two output connections. In order to get two input connections and two output connections, out of these three we have to make one of the either emitter, either base or either collector as a common connection, and this configuration is called as transistor configuration, based on whether we have made the base common, whether we have made the emitter common or whether we have made the collector common. There are three types of configurations in a transistor, and these are common base connection, common emitter connection, and common collector connection. Let's see what is common base, common emitter and common collector connection one by one. We will start with common base connection. In this common base connection, we have to make the base of the transistor as a common to input and to output. Here, one NPN transistor circuit and one PNP transistor circuit is shown. Here it is emitter, here it is base, here it is emitter and here it is collector. If you observe, the base is made common, means input is given in between emitter and base. Input is given between emitter and base, and output is taken across collector and base, and output is taken across collector and base. It means that we have made the base as this base as a common circuit element. Therefore, here we are applying in between emitter and base, we are applying the input, and in between collector and base we are taking its output. Here in collector circuit we are using the load across which we are going to measure its output. This is the circuit diagram for NPN transistor. Now we will see what is the gain of this common base connection. What is gain? Gain is nothing but ratio of output current to the input current. What is gain? Gain is nothing but, it is called as gain or amplification factor of common base configuration or common base circuit. So what is gain? It is the ratio of, it is the ratio of output current to the input current. Hmm. Gain is nothing but the ratio of output current to the input current, and gain is shown by the letter alpha in case of common base connection, and hence here input current is nothing but the emitter current and output current is nothing but the collector current, and hence value of alpha, that is gain, is equal to IC upon IE. Value of alpha is IC upon IE. In our previous lecture, we have seen what is the emitter and how it is formed, what is the base and what is the collector. In case of emitter, in case of NPN transistor, the majority charge carriers are the electrons and it is heavily doped. The middle portion of the middle portion middle portion is made up of, it is base, this is emitter, this is collector. The length of collector is more as compared to base and emitter, and this is made up of p type of material, this is made up of n type of material, and this is made up of n type of material. And we know that when we biasing, when we do the biasing, then the emitter base junction of the circuit is always forward bias and this is reverse bias. Here we are applying forward bias and this circuit is always reverse bias, and hence when we forward bias this circuit, then the electrons which are present in the emitter, they starts to migrate towards the base, and base consists of holes, and there is possibility of electron and hole combination, recombination, and because of that there is generation of base current IB. Hence here emitter current is there, then due to the loss or the recombination process there is the formation of base current, and here we will get IC, that is collector current, that is after base the current will flow from base to collector, and here about 5% of the electrons volts will get recombined, will have undergone recombination process, and remaining 95% electrons will contribute for IC, and hence you will see that in case of common base configuration, IE, value of IE is always greater than value of IC. Why is it so? Because just now we have seen that IE is nothing but IB plus IC. So if we apply this rule, that is this formula, alpha is equal to IC upon IE, then as IE is always greater than IC, hence this alpha will always be less than or equal to 1. So value of alpha, that is amplification or gain, will not be greater than 1 in case of common base connection. In case of common base connection, value of gain will always be less than 1. So let's revise the things. In case of transistor configuration in common base connection, in order to have a common base connection, we have to make its base common. That is, input is given in between emitter and base, and output is taken across collector and base. Resistor is applied in between collector and base circuit. So gain can be found out by using the formula output current divided by input current. Here output current is nothing but IC, that is collector current, and input current is nothing but the emitter current, and hence their ratio will give us gain or amplification factor for base common base connection. Then just now I have explained the theory behind why alpha is less than or is equal to 1 in case of common base, because in case of common base, if we forward bias this emitter base junction and reverse bias base collector junction, then what will happen? The electron will try to migrate from emitter to base, but in base there will be electron hole recombination process which will produce the current IC, IB, that is base current, and remaining 95% of the electrons will get migrate towards the collector and they will form IC, and hence IC IE is equal to IB plus IC, and also alpha value will always be less than 1. This is the explanation related to common base connection in case of transistor. Thank you.